So today let's look at right triangles. This is where one of the angles in a triangle is a right angle. And the shortest distance from a point to a line is a perpendicular segment. And where this is not true, of course, you could draw a longer side. And of course, if it's the longest side, then it's going to be what's called the hypotenuse, or the opposite side of the right triangle, of the right angle. The other two sides in a right triangle are called legs. Now, all of this works together with the Pythagorean Theorem, which some people call the fundamental theorem of geometry. A squared plus b squared is c squared, where c is the hypotenuse, or the longest side. When you're given a right triangle, let's try a problem where the legs are 3 and 4. Draw a picture. Can you find the hypotenuse? Of course you can. We use the Pythagorean Theorem. By plugging in the a squared plus b squared is c squared, you end up with c is equal to 5. And this is quite amazing. It's what's called a Pythagorean triple, because all the sides are whole numbers. And that's really amazing because that's not usually the case. Now, this is called a relative prime Pythagorean triple. If you were to double the side lengths, for instance, you could get 6, 8, and 10, or triple it, 9, 12, 15. These other examples are not relative prime. The 3, 4, 5 is a relative prime. Let's try another problem where the legs are more typical, like 4 and 8. And if you were to substitute in 4 and 8 for the legs, you'd solve for the hypotenuse, you'd end up with the square root of 80. Now let's simplify that. That's 16 times 5. Well, the 16 can come out of the radical because it's a perfect square. So the square root of 16 is 4, but the radical 5 cannot. So 4 radical 5 is my answer. Now that's a number that's somewhere between 8 and 9. It's closer to 9. It's like the square root of 81 is 9. What if instead we said the sides were this? Now we already did the one where it's the hypotenuse, but what if the hypotenuse were 8? Well, you could solve for this and then get the square root of 48. Well, let's see here. Square root of 48 simplifies to 4 radical 3. So there's two different possibilities if you look at the sides. Why would this not make sense? It makes no sense to put the 4 as the hypotenuse. The longest side has to be the hypotenuse, and we knew that. Now, what kind of triangle is this? It's equilateral. It means it's also equal angular. All the angles are 60 degrees. And we're curious as to what is this third side. What is this longer leg? If you do the hypotenuse, the Pythagorean theorem, you end up with the square root of 3. Well, that's interesting. Well, let's double the sides and try the same thing again. Here we end up with the square root of 12. Well, that simplifies. Of course, it's 4 times 3, so the 4 comes out of the radical. 2 radical 3. Oh, and if you do it again, you end up with 3 radical 3. This is amazing. This radical 3 keeps coming up again, over and over again, the radical 3. And that's always on the longer leg, the one that's opposite the 60-degree angle. Well, yeah, you know you have the one triangle. Oops, I wrote that wrong. That should be a 1. Yeah, each one of these are the same. If you think of it's half an equilateral, the hypotenuse is double the shorter leg. The longer leg is root 3 times the shorter leg. It's a special right triangle. 30, 60, 90. Think half an equilateral, hypotenuse is double the shorter leg. Knowing this will keep you out of trouble, and the longer leg is root 3 times the shorter leg. Now let's look at another special right triangle. 45, 45, 90 right triangle. This is, if we do the a squared plus b squared c squared thing, we end up with c is equal to x times radical 2. And that means that if x were 1, and the side lengths were 1, 1, and 1, then the side length would be 1 times radical 2. Well, here you have 4 and 4. It's going to be 4 times radical 2. Whatever the legs are, times radical 2. Ah, but what if the hypotenuse were 8? This is the harder problem. Uh-oh. What do we do now? Substitute in 8 for the hypotenuse, and if you draw it like this, you'll see that it's 4 times radical 2 is x, and substitute in x times radical 2 to get its 8 and